Martin Rowe with EE World. We are at the Tandon School of Engineering at the NYU Brooklyn campus. This is the 6G Brooklyn Summit, and Michael Zappi is going to talk to us about SDRs. And Michael, why don't you show us this demonstration that you have here, this equipment that you have here?
Sure. So here we have equipment. We have an earlier SDR, which is one of our V-band, 8-channel, fully digital SDR.
What frequency range is V-band?
That's going to be 60 gigahertz.
60 gigahertz, okay.
Yeah. So it also has the ability to calibrate the phased array itself.
Okay.
So saving having to get two radios and calibrate off each other.
So how many this phased arrays look like? You've got what, 16?
8. So
by
8 elements. They're,
okay.
Linear patches. Series there, so we get good elevation gain, and then we're able to steer an azimuth using the 8 linear arrays.
Okay, and what's the second one over here?
So this is our new FR3 unit. This is actually a test board. We've designed the unit, which you can see over here, and we took the circuits off of this, put them on the board just to ensure their correctness, be able to tweak filters and play around with it. And so we've built this single channel unit, and we have it connected. So we have two 6.5 gigahertz antennas there, and two 12 to 18 horns. We're running 17 gigahertz through them.
Okay. FR3, for people who don't know, FR3 is, I would say, to some extent undefined, but to some extent, we know it will fall somewhere between, I've been hearing 7 to 12, 7 to 15, 7 to 17 gigahertz. The point being somewhere between FR1, which ends at 6 gigahertz thereabouts, and millimeter wave starting at 24 gigahertz.
Exactly, and that's why we've built this board to be able to address between 6 to 24 gigahertz in a single SDR. So the demo we have here is showing the switching between the two, and right now we wrote a simple MATLAB script, so it's not showing exactly how fast you can switch, but this is microseconds to be able to switch between frequencies, and that'll allow you to look for transients that happen in both channels. So one of the big questions we have is, what are the FR3 channels going to look like? Especially as we consider new uses and new models involving things like the height of buildings in urban canyons, and just generally, can we just extrapolate from the FR1 models, or do we need to account for new things? Another major thing in the FR3 space is that there are many incumbent users, including a lot of satellite users.
That's right.
So you now have to worry about signals going up and signals going this way, say diffracting around buildings and interfering possibly with other people's satellite reception. So in order to facilitate research into this area and to be able to do measurement campaigns and make sure we figure out what's going to work well, we're designing this, we've designed this SDR to be able to work between 6 and 24 gigahertz, and then we have an antenna board that comes with it by default, which has 4 different phased arrays, which allow you to steer and do fully digital beamforming on both transmit and receive. So you don't have to just point in one direction like you do in most phased arrays with phase shifters, but you can actually computationally extract beams from the data you gather. So for channel sounding, this is an amazing device. And we also hope to facilitate wireless experimentation for anything ranging from research down to just letting students get their hands on these devices and learn practically, so we can train new engineers to be able to work in this new frontier of 6G.
And your company, what's the name of your company?
Pi Radio.
Pi Radio. Oh yes, that's what we have right here. Let me zoom in on that.
Yep, from Pi Radians. So.